The James Webb Space Telescope, which is operated by NASA, is credited for capturing the clearest and most detailed infrared image of the distant universe to date. Galaxy cluster SMACS 0723 is Webb's first deep field, and it is filled to the brim with hundreds of galaxies, including the objects that have been seen in the infrared as being the weakest yet seen. Hello everyone, and welcome to TechTonic. Today, we'll be looking at how the James Webb Space Telescope just discovered a huge structure at the center of the Milky Way. Yeah, you heard it right. So, let's start our video. The image captured by Webb is about the size of a single grain of sand when held at arm's length. It is a minute portion of the enormous universe. This galaxy's cluster combined mass works as a gravitational lens, magnifying more distant galaxies, some of which were visible when the universe was less than a billion years old. This deep field was captured by Webb's near-infrared camera, and it is a composite made from images taken at different wavelengths for a total of 12.5 hours. This allows it to achieve depths at infrared wavelengths that are beyond those of the Hubble Space Telescope's deepest fields, which took weeks to achieve. Moreover, we're just scratching the surface here. The Webb Space Telescope so that longer exposures of our enormous cosmos can be obtained. This image depicts the galaxy cluster SMACS 0723 as it appeared 4.6 billion years ago, with a significant number of other galaxies located both in front of and behind the cluster. When academics start looking into Webb's data, they'll discover a great deal more information about this cluster. This region was also observed by the mid-infrared instrument Milky on Webb, which detects and analyzes light in the mid-infrared spectrum. Through the use of Webb's NIRCam, faraway galaxies have been brought into clearer focus. These galaxies contain structures that are so small and faint that they have never been seen previously. The light that came from these galaxies traveled here over a period of billions of years. When we see the galaxies in this field that are the youngest, we are going back in time to a period that is less than a billion years after the Big Bang. Because of the expansion of the cosmos, the light has been stretched to infrared wavelengths, which Webb was specifically built to observe. Soon, scientists will start to acquire additional knowledge on the masses, ages, histories, and compositions of the galaxies. In addition to such qualities, the strong gravitational field of a galaxy cluster has the ability to bend light rays from more distant galaxies that lie behind it, in the same way as a magnifying glass warps and bends images. Stars, which are shown to be more luminous at shorter wavelengths, are also depicted with strong diffraction spikes in these images. The Milky image captured by Webb displays a kaleidoscope of colors and highlights where the dust is located. Dust is an essential component in the development of stars and ultimately life itself. Blue galaxies have stars, but relatively little dust in their structures. The red items in this field are completely obscured by the enormous layers of dust that are covering them. The constituents of green galaxies includes hydrocarbons and a variety of other chemical substances. Researchers will be able to comprehend how galaxies form, grow, and merge with each other, as well as in some cases why they stop creating stars completely by using data such as these. Two of Webb's instruments were able to obtain spectra, which are data that reveal an object's physical and chemical properties. These data will assist researchers in this field in identifying many more specifics about distant galaxies. In addition to taking images, Webb's instruments were able to obtain these spectra. The near-infrared spectrograph microshutter array on Webb observed 48 distinct galaxies at the same time, a new technology that was deployed for the first time in space, and it returned a complete set of information on each galaxy. The data presented light that originated from a single galaxy and had been traveling for 13.1 billion years before it was captured by Webb's mirrors. Data from NIRSpec also illustrate how much more detailed galaxy spectra will be once Webb observations are completed. Finally, Webb's near-infrared imager and slitless spectrograph NIRISS use wide-field slitless spectroscopy to collect spectra of all the objects in the entire field of vision at the same time. This was accomplished by removing the slits from the spectrograph. One of the conclusions that might be drawn from these findings is that one of the galaxies contains a mirror image of itself. The SMACS 0723 galaxy can be found in the southern sky, close to the constellation Volans. The James Webb Space Telescope is widely regarded as the most advanced space observatory ever constructed. Webb will investigate the enigmatic architecture and origins of our cosmos, as well as our place in it, as well as solve mysteries that exist inside our solar system and look beyond to more distant worlds that orbit other stars. Webb is a multinational effort that is being led by NASA in collaboration with the European Space Agency and the Canadian Space Agency. The Science Mission Directorate is in charge of the mission, while NASA headquarters is in charge of overseeing it. The Goddard Space Flight Center in Greenbelt, Maryland, which is operated by NASA and operates Webb on the agency's behalf, is in charge of supervising the work that the Space Telescope Science Institute and Northrop Grumman, together with other mission partners, do on the mission. In addition to the Goddard Space Flight Center, several other NASA centers such as the Johnson Space Center in Houston, the Jet Propulsion Laboratory in Southern California, the Marshall Space Flight Center in Huntsville, Alabama, the Ames Research Center in California, Silicon Valley, and others all made contributions to the project. And that's all for today's video. What are your thoughts on this? Let me know in the comments section down below. I hope that you found this video interesting, and if you want to see more videos like this, please consider subscribing to my channel. See you in the following video with some more of the latest updates, and until then, stay tuned.